In the previous session, we have discussed about soldering of the various components. To begin with, we have soldered a few components, namely these 4 LEDs, 4 SMD resistors, and the burge strip to mount the microcontroller, and just a 3-pin jumper at DHT11 to verify the input section. So in this session, we will write a program and let's verify whether the entire the system, right from the connectivity to the controller to the interfacing, is working or not, like inputs and outputs. And slowly then no, we will populate the rest of the external components, and then we will also discuss about the programming part. So since there are 4 LEDs are there where we have connected on IO27, IO14, IO12 and IO13. So how to test these LEDs? So if you look at the program where there are two loops, void setup and void loop, as usual in Arduino compiler. Void setup, whatever you write is executed only once. So here we said 27, 14, 12, 13. Wherever LEDs are connected, we have configured them as an output port because the direction of the data is to the outside world. So the keyword for IO configuration is called pin mode. So pin mode is specific pin and output. So since we are interested in 4 LEDs, so we have written the same code 4 times with different port numbers. So what is this 27, 14, 12, 13? They are nothing but you can see on the your controller, right? The GPIO numbers, like what is called D14, right? Or D27, D12, D13, or maybe the last page if you refer, you have more clarity. Every GPIO has a number 36, 39, 34. So what right now we are talking about is these pins 27, 14, 12, 13. These are the pins where we have connected the LEDs. So the CPU has a specific pin numbers. In the compiler, we must port the same pins for the programming purpose. All right. So if you, after hardware initialization, the void loop, which is an infinite loop, what we are saying is digital write. Digital write means only two states, either active high or active low. So first to begin with active high, because if you look at the how the LEDs are connected, right? The LEDs are connected here in a common cathode manner. That means if you give here 3.3 volts, nothing but high state, the LED will be forward biased. So that's the reason where we said high. High means on. So 27, 14, 12, 13, 4 LEDs and one delay function, so that between on time and off time we should be able to differentiate. In my earlier session, I also discussed about PWM mode, how to control the duty cycle, frequency, and so on. Alright, the other keyword is digital write. This time it's a low state. Low means 0 volts. So 0 volts is applied. And since it is in the loop, a perfect 50% duty cycle square wave is generated with 200 milliseconds on time, 200 milliseconds off time. 27, 14, 12, 13 is in high state, and after that again they will be in the low state. And before you download the program, make sure in the device manager IO ports your CPU is recognized Silicon Labs CP210 with specific port number. So in the program also tools, the board should be do it ESP-32 dev kit V1, you should select it, and the port, whichever is a port, COM3, if you see here it is COM3, so that should be selected COM3 here in the port. Okay, so once selected, you can see bottom side of the screen right side, do it ESP-32 development kit V1 with a COM port of COM3. Alright, so that's called interfacing. Now let us compile and download the program. That is the right arrow key. So now the program is getting compiled. Once it converts the high level languages into low level language, that is binary code, then it will also transfer the code to the flash memory of the CPU, what is called in-system programming, ISP mode. And with the downloading speed is, you can see 9,21,600 bits per second is the transfer speed. Whatever you select, accordingly with that speed it will transfer the program. Once the program is 100% transferred, then it will start executing. So actually the CPU is switching between the ISP mode and the application mode. So when you are downloading, it is in ISP mode, means loading the program with the help of the bootloader. And once the program is loaded, it will switch to the ISP mode. Or if you reset, there is a reset button next to your USB connector. Even by pressing the reset button, the program will be executed from the beginning, from the starting location of your application program. So this green bar indicates the compiling status, and in the command window it will show the code, how much percentage of code is transferred from the computer to the flash memory of the CPU. Alright, so you can see once the compilation is done without any syntax errors, now the board is getting connected. Now it's throwing a error. Error means now some problem is there in the COM port. It's unable to transfer the code to the board. So that you need to verify any hardware problem is there or not. Alright, so the program is loaded. Now if you see the results on the board, the four LEDs which you have soldered is start blinking with 200 milliseconds on time and 200 milliseconds off time. So that confirms your soldering is okay, LEDs, resistors and the microcontroller and the interfacing part. So let's see, one by one we'll solder each and every component, we'll write a program and verify the board. So that's about this tutorial, just verifying the hardware. Now, like I was telling about the sensors part, right? We will connect one sensor at a time, the various types of sensors. We will solder it and we will test it, whether every sensor or every peripheral which we have interfaced, solder it and test it. That's how this tutorial goes. So if you look at the list of the components, we have soldered R2, R3, R4, R5, which are connected to LEDs, right? So these four LEDs, LED1, LED2, LED3, LED4, R2, R3, R4, R5, which are 330 ohms SMD resistors, right? Which are placed over here, R2, R3, R4, R5. So there is one more 330 ohms resistor, SMD resistor is there. Let us complete R11. So once you finish all SMD components, then we will go to the rest of the components. The reason why immediately we have soldered LED and controller burge strip is if there is any short circuit on the board or open circuit on the board, if the controller is not functioning, then there is no point in populating the rest of the components, right? If the CPU is not working, if the brain is not working, then your program is not working. What is the point in populating the components? That's why the minimum components, LED is a minimum component, and then CPU, the minimum system has to be soldered. So just to verify the brain is working, the program is working. Now you can, as per the convenience means the smallest components first, then the bigger components. Accordingly, we should populate. Alright, so since one more component is left, R11, 330 ohms, find out where is R11. So R11 is here, that is above PC817, this component. Let us solder 330 ohms. So you can see above PC817, R11 is there. Let us solder this. Like I said earlier, one dot you have to first solder it. Then with the forcip, hold the resistor, 330 ohms resistor, and heat the metal which is already soldered. Make it the liquid state. So once you place one end of the component, take the solder metal and the other side of the pad, square pad, you can solder it by placing the gun and metal together at 45 degrees and melt the metal on the pad. In short, as I said, heat the pad. Yeah, that completes the R11. Now let us take the other components. The other components is 1 kilo ohms resistor, which are there R1, R9, R12, R13. So 4 resistors, SMD resistors, 1206 size, that's the dimensions. So on your PCB, find out first is R1. Okay, so you can see R1 here above LDR, R1 is there. So take 1 kilo ohms. R1 is placed. Now similarly R9, R12, R13. So they are there. R13 is next to LED. R12 below the Q3 transistor, that is R12 here below the Q2 transistor. R9. R9 is next to optocoupler. Okay. So since all four of them are soldered on one side, let's solder the other side. Yeah. So that completes the 1 kilo ohms resistor R1, R9, R12, R13. Next, let's find out R6 and R8. So R6, R8 is here, R6 is here. Both of them are 100 ohms. R6 slightly push towards the soldering gun so that you have ample space for soldering the second pad. And R8, which is next to optocoupler. Alright, since now solder the other side. Yeah, that completes the 100 ohms. Now 10 kilo ohms is R7. So R7 is next to R6, 10 kilo ohms. The other side of the pad. That completes R10. Sorry, R7, 10 kilo ohms. Now R10, which is 2.2 kilo ohms. So where is R10? R10 is near that sound connector R10, which is meant for LCD to adjust the contrast of the LCD R10, which is 2.2 kilo ohms. Alright, so this completes all SMD resistors. Now let us solder few biasing capacitors, or we also call as a decoupling capacitors, which are 0.1 microfarad. C1, C2, C4, C5, C6. You can find out the capacitors, which are generally kept near the ICs, right? There is a CD4051, C2 is there, C3 is there above that. At least a few wherever possible. C1 is near power supply, right? So at least these 3, 4 decoupling capacitors which are meant for to stabilize the power supply so that no ripple will be there on the DC line. So what we will do is we will remove the microcontroller. Let us solder the decoupling capacitors. Any side you can solder decoupling capacitor. There is no polarity first of all, so there is no direction, and any side because there is no color code is printed. Be careful, do not touch any plastic parts while soldering the components, otherwise you will be melting the connectors. Let us solder the other side. So that completes the all the SMD components, serial number 1 to 6. These are SMD. So since SMD components are soldered, that is resistors and capacitors, now let us solder the SMD ICs, right? Because again, there will be a challenge here while soldering the SMD ICs. I will show you. There are two ICs are there, SMD ICs. 74HC595, which is a 16-pin SO IC. Then CD4051, again a 16-pin SO IC. So two SMD ICs are there. So where are they? This is one IC. This is the second IC. Before you solder it, first apply a liquid flux on the pads. Apply both sides of the pads, the flux. Then place the SMD component IC looking at the pin number 1. Pin number 1 you will always see some notch. So that pin number 1 should be placed where the label IC number is printed. So find out first is 74HC595. Where is there? So 595 is here. That is above the relay. 595 is there. So there you can see there is a notch. So pin number 1 should appear here, top left. Place the IC exactly on the pads, center to the pads. will notice there is a line on top of the IC or notch. So it should be on the center of the pads. Now by holding the IC, solder one pad on left side, one pad on the right side. Take some metal on the soldering tip, hold the IC with forceps. One pad is solder on left side and one pad on the opposite side, some other corner. Put some metal. Now the IC won't move. What you do is take some slightly, very as less as possible. Take the metal as shown to rub the pads and clean it. Rub the pads and clean it. Very little metal should be there on your soldering gun tip. Now place the other IC CD4051. Look at the notch and place exactly center of the pads. The notch should be where the name is there. Take some metal on the solder tip. Hold the IC with forceps. Put the metal on left side, at least one or two pins. Put the metal on the right side, the other corner. Now take little metal, not more, little, very as small as possible, and rub the pins horizontally. Similarly, take less metal as small as possible. Rub the other side of the IC. Now clean it. That's it. So it completes the SMD. You can see it should shine. No metal should be there between the pads. You can see in the magnifying glass if there is any metal is there. Of course, we should clean it with the help of some liquid cleaner that we will do it later on. Okay, that completes the SMD resistors, SMD capacitors and SMD ICs. Now all other components have holes. So now you do not have any problem because the soldering is not done on the top side. The way we have done this burge strip on the back side of the PCB, right? We have done the soldering. Now also all the components we will solder it on the back side where these holes are there. They are called the pads or plated through holes for soldering these lead based components because all of them have leads. So we won't solder the connectors, means we won't solder the burr strip first. First we will solder the components first. Means a serially if you go by, first there is a diode D1 1N4004. So take the diode and solder it first. So the diode D1 on your PCB is here, which has a direction. You can see the silver band is the cathode. So the silver band on your diode should go on the same direction. So bend the diode right angle exactly nearer to the diode. Take some nose plier. So exactly right angle, bend it. Now you can see there is a silver band. This silver band should go wherever silver band is there. Okay. So insert it properly. It should settle. It should not be hanging. Reverse the PCB. Take the metal and put the metal and gun on the pads. Heat the pad. Yeah. So now let's cut the extra leads. Hold it so that it should not fly. Cut it. So that's completes D1. Now the next component is Q3 NPN transistor BC547. The transistor BC547, that is Q3, is here. As per the nomenclature, it is Q3 NPN transistor, which is there here, right? Q3. It has a direction. Look at the flat portion. So exactly the flat portion, you can see the flat portion should go match all three pins, emitter, base, collector, and insert it properly. It should settle down properly and tilt it. Heat the pads, put the metal. Cut the extra leads. Yeah, so we have finished transistor Q3. Now regulator 7805. Where is it? 7805 regulator. It is here. 7805 looks like same, but it's a regulator, voltage regulator, which will give you constant 5 volts. Place it. Look at the flat side. Exactly, the flat side should match. Place it properly and solder it from the bottom side of the PCB. Cut the extra leads. Alright, so that completes both the transistors BC547 7805. We have soldered both the ICs. Now there is a sensor, light dependent resistor, LDR. Where is LDR on your PCB? LDR is here. So solder the LDR. There is no direction for the LDR. Insert it properly and solder it from the bottom side. Cut the extra leads, hold it, extra lead and cut it. So that lead should not fly and hit your eye. Alright, LDR is done. Now there is a TV infrared sensor, TV remote sensor, TSOP 1838. This has a direction. As you can see, the open window. So this window should be flat side is back side and window should be outside the PCB, right? It should, this window, or you can say receiver, the diode should be outside the PCB. Okay, the flat side is back side. So tilt it, should not fall, slightly bend the leads so that it should not fall. Keep it straight, the leads. Solder the pads and cut the extra leads. Hold the leads and cut it. All right. So we have soldered two sensors. There is another LED, but this time it's not SMD LED. It's a 5 mm LED, normal LED. The diameter is 5 mm. Where is it? So it is near the relay, this 5 mm. Now let's see, there is a direction, positive anode, cathode is this, means flat side is a negative. So long side, long lead of the LED should come positive side, short lead should come to the flat side, negative side. So if you see the LED, long lead, this is, short lead is this. So long lead should go towards the positive side. Flat short lead should go to the other side. Or I also said there is some flat portion is there on the LED. This flat portion and this flat portion should match. Anode and cathode, be careful, otherwise it won't work. Hold it or bend it, otherwise it will fall. With one finger, hold the LED and solder the lead or bend the leads so that it won't fall. cut the extra leads. Yeah, that completes the 5 mm normal LED. Now you have the connectors, DC motor 5 volts connectors. Okay, let's see where they are. So the connector for the connecting the motors, both the DC motor is here. So you can take 5-pin male purge connector. So the direction, as you know, you can, there is an indicator pin number 1. The direction should be this side, right? If you can carefully see, there is a slot. This slot is outside the PCB. The reason is when you connect the motor connector, DC motor connector, you can see how it fits. The yellow color wire, just a color coding, actually there is no difference in the wires. So the yellow color is coming nearer to the star. So that's the reason, just for a locking purpose, we kept this connector, DC motor connector, which is outside. This slot is outside the PCB. It should not fall, so hold this with one finger, any one finger, and now solder from the bottom side. Just solder one pin, then it won't fall. Peacefully you can solder the rest of the pins. So no need to hold it. So make sure minimum metal, no round shape. It should be like a mountain. Spread it across the pad, uniform. Yeah, that's the motor connector where the slot is outside. So two DC motors we can connect it there. Then there is a relay, DC relay is there on the board. So the relay is here, you can see. So solder the relay. It has a direction, you can see 3 pins on left side, 2 pins on the right side. All right. So hold it and tilt it. Keep your finger so that it should not fall. At least solder one pad and then you can solder the rest of the pads. Fill the hole. All right, so that completes the soldering of the relay. Then there is a LCD connector 16/2 barge strip, which is 16 pin. You can see the connector. This time the barge strip is male. Break this 40 pin barge strip into 16 pins, either by placing here
Make sure the smaller portion should go inside the holes. Larger portion should be outside. Right, exactly 17th pin, you should break it. But you can break it by hand also. So exactly 16 pin burge strip. Smaller portion should be inside the pads. Larger portion should be outside the PCB. Hold it with one finger, tilt it. It should not fall, and at least solder one pad, maybe the center one, so that it won't fall. Okay. Now you don't need to wait for a few seconds. Once it dries, then you don't need to hold your finger. You can solder rest of the 15 pins. Take minimum metal, and the metal should flow on the entire pad on both sides, not one side. Move your gun if it is melting only one side. Move your gun to the other side. And make sure adjacent pads are not shorted. All right, so it should be uniform, shining, minimum metal, no adjacent pads are shorted. If adjacent pads are shorted, clean your gun tip and clean this metal. Just move between the pads. If there is any metal is there, just move it like this, like this. Move it very fast. The metal will be deposited on your tip and clean it. That's it. So no short circuits between the pads. That completes the LCD connector. Then we have motor clamps. So mounting the motors we will do afterwards. There is a power connectors, right? So for relay 2 pin, and for relay 3 pin, and for power supply 2 pin, power connectors are there, screw mounted power connectors. When you mount it, make sure the screws, you can see the screws where the wires will go inside. They should be visible outside the PCB. The 2 pin power connector, where is it? Here, right? Or on your PCB, the component placement, it is here, right? What is written as a 6 volts, 9 volts battery connector next to your infrared sensor. So while mounting this, make sure these holes, right, where the screws are there, they should be outside the PCB. It should be outside these two screws, so that the wires are connected from outside. Hold with some one finger, solder it both sides of the pads, complete round. Okay, now the holes you can see it is outside. Similarly, take the 3 pin connector. Again, you see the screws. They should be outside near the relay, outside the PCB. Tilt it, hold with finger. You can see the screws are outside the PCB.
That completes the power connectors where they can withstand high voltage and currents. One is for battery connector, other is for the like fans, tubes, bulbs, because it is across the relay. USB cable we will give you later on, and even 9-pin battery connector we will give you later on. Motor connector also we will give you later on. Dummy wheels we will give you, vehicle tires we will give you, microcontrollers we will give you. Now the potentiometer, you can see the potentiometer 10 kilo ohms 3296 means multi-turn potentiometer. So later on your PCB 10K preset, you can see here 10K preset. So the multi-turn preset, this is the screw, you can rotate it 10 times. There is no direction. Put it into the preset 10K preset slot, hold with finger, tilt the PCB, solder the pads both sides, make sure metal should not fall neighboring pads. If there any problem, immediately report to me. I will guide you. Don't take your decisions, cut the extra leads. Because if you make any mistakes while soldering, you may permanently damage the pads because they are double-sided plated through holes. So we have completed the potentiometer 10 kilo ohms. Now there is a temperature sensor connector. These are all connectors, right? That we will see all the connectors. Barge strip female connectors, humidity connectors and all. There is a push to on switch, item number 30. So push to on switch is here, on off switch. You can see on off switch. Of course it has a direction, means press. It is up to you. Even if you change the direction, nothing will happen. Instead of on it will off, instead of off it will be on. Press means generally we expect on, release means off. If you reverse the direction, it will work the other way around. That's the only thing it will happen. As you can see, there is a indication, some notch is given. So on your switch below that, there is a notch, right? There is a hole is there. Put it exactly opposite direction. Means this notch should be opposite to this white colored mark, right? So since this is a hole, I will put it the other way around, but slightly you have to expand this connector because the pads are not matching. So slightly you have to bend it, expand the outside connector and insert it to these 6 pads. Press it properly so that it will sit, it should sit properly. Okay, then tilt it, solder all 6 pads. All right, so that completes the on off switch. This switch is meant for giving the external power supply.
these three, this connector, external power supply on off switch, right? When you want to give the power through battery, that time this switch is useful. Okay, so that completes the this thing. Most of the components we have soldered. What you can see is, now I will give you some IC socket, 16 pin DIP socket. Now we are doing all the sockets now. This is meant for mounting the motor driver. It has a direction. By mistake, if you reverse, nothing will happen. But still, there is a notch, and wherever this notch is there or the IC number is printed, insert in that direction. All 16 pins should match. Change the direction. Solder all 16 pins uniformly with minimum metal. If you solder one pad, no need of holding the IC. You can solder the rest of the pads. Why we are soldering all these plastic parts is because by mistake, if your gun touches this plastic material, it will melt. So better all these plastic connectors you solder at the end. So that's it. Now we have a buzzer. We'll give you buzzer, some temperature sensor, other sensors, as and when you buy, you can solder it. These are all optional things based on your project, but at least buzzer will provide. It has a direction. You can see positive is written plus. So wherever the round shape is there, right, the positive should come inside the PCB, right? This plus is inside the PCB. Tilt it, solder the pads. All right, so that completes the this thing. Take 2-pin burge strip male, put it here on JP1, which is nearer to that motor connector. But male, burge strip male, because it is a jumper. I will tell you while using the motors what is the purpose. So burge strip male 2-pin, solder it. All right, so that completes the soldering. Now what we do is, I will show you one connector. You can solder the rest of the connectors. So the way I have done DHT11, this burge strip female, you solder it for all the connectors. Means on your PCB for sensors, right? We have kept several connectors other than JP1, which is a male. All other like sharp, IR LF1, IR LF2, ultrasonic, IR LF3,
Servo, you put it again male. Let's solder the servo also. 3-pin burge strip male.
This is male like JP1 or LCD 16 pin connector. Alright, so servo is also
Burge strip male. Otherwise, all other connectors. Now vibration, DHT we already done. Pressure sensor, accelerometer. You have touch sensor, IR-MR, IRB, IR-ML. All of them, and sound here. All of them solder the burge strip female. Connect it to cut it to the appropriate size. Take the burge strip female connector. Let's say for example you want 4 pin.
exactly cut the fifth pin, right? 1, 2, 3, 4. So fifth pin, place your cutter on the fifth pin, cut it. Now take the sandpaper, rub it so that it should be a flat, so that no confusion will be there while mounting the sensors. Uniform, no extra plastic. Now, like that, make several of 4 pin or 3 pin. Now you can connect it, you can mount it wherever those sensor sockets are there. Hold with one finger, tilt it, and solder the pads. Quickly do it because it's a plastic. Once your entire soldering is done, we are almost done. Yeah, one IC we have forgot. You can see there is IC and optocoupler. I will give you both the, we forgot actually. Right, so there is a optocoupler, there is a PC817 IC is there. So in the list, right, we have somewhere optocoupler, right, MOC 7811, item number 15. So that we have missed. So while mounting, you can see the IC number PC8, the optocoupler, right? MOC. So this name should be outside the PCB. Match all 4 pins. And make sure this name should be outside the PCB. Name of the optocoupler should be visible from the outside the PCB. So all 4 pins are placed, leads are placed in the socket, pads, solder the pads Do it quickly. It's a plastic. And cut the extra leads. Alright, so we have soldered the optocoupler, which is also a sensor, optical sensor. Then we have forgot one more sensor. It is also a sensor or driver, relay driver we are using in our case. That is IC PC817. Actually, these are all sockets. Actually, no, there is a 4-pin IC. L293D, we have soldered 16-pin IC. Now PC817 is again a optocoupler driver for driving the relay. Alright, so how do you know the 4 pins? If you see the IC, there is a dot, that is pin number 1. On your PCB, wherever PC817 is written, so towards that, pin number 1 should come, dot should come. Alright, so this dot and PC817 should be closer. That is pin number 1. Hold with finger, tilt it and solder all 4 pins. Alright, so that completes the both the optocouplers. One is for obstacle detection, other is to drive the relay. We have done that. So now, as I said, this Burge strip female, you can populate in the rest of the connectors, right? These connectors. And after doing this, all right, you take the multimeter and verify is there any short circuit while soldering. At least the power supply should not be shorted. So take the multimeter, keep it in the continuity mode. You can hear the short circuit sound. If you test it on your PCB, on your LCD first pin and second pin, it should not be shorted. Or the 15th pin and 16th pin, it should not be shorted. That means at least you have not shorted the power supply. Means what? What is the significance of this first and second or 15 or 16? If you see your LCD connector, okay, the LCD connector, all right. So first is ground, second is 15, 5 volts. Similarly, last pin, 15th pin is supply, 16th is ground. So these two pins, anyhow, they should not be shorted. So while doing soldering, by any chance, if they are shorted anywhere on your PCB, then do not give the power to the board, do not mount the microcontroller. Okay, if everything is okay, then collect the microcontroller and this USB should be towards your buzzer or the switch. Match 15 pins on the left side and 15 pins on the right side. And properly insert it. So the USB, always remember, should be towards the your buzzer or the switch. So if there is no short circuit, then once again check by any chance 3.3 volts is shorted or not. This is the second power supply. So
Where will you see the 3.3 volts power supply on your board? If you remember on your microcontroller, right? This side, that is your right side, first pin is 3.3 volts, second pin is ground. That means carefully if you observe here, this first pin is 3.3 volts, second pin is ground. Again verify with the multimeter, first pin and second pin should not be shorted. So no short circuit. If that is the case, that means 5 volts ground, 3.3 volts ground should not be shorted. At least your soldering some extent is okay because you have not shorted the supply. Now you can give the power to the board because it's not showing the short circuit. Connect the USB cable. It will go in only one direction. It is in a D shape, right? You can see the locks. Match the locks, or the bigger portion is on the upper side. If you connect it to your USB of the computer, then on your board, the LED, right? Your LED on your board, that power supply be blinking, right? That's how it should be if there is no short circuit. All right, so that completes the at least minimum testing, minimum soldering. Populate the rest of the barge strip female connectors. That completes the soldering part. Then we will see the programming part.